This is officially our last section of material for this semester, and everybody breathed a sigh of relief, right? We're starting the last bit. It's really a continuation of the previous section. In our previous section of material, we took 3 equations and 3 unknowns, and we solved for the 3 unknowns. And we're going to be doing the same thing in this section, except that we're not going to be given the equations to start with. We're going to have to create them. I'm going to continue just to use x, y's, and z's since we're kind of comfortable with that notation. There's nothing special about those, so if you want to use different letters, as long as they don't get mixed up with your numbers, go for it. So here's our first example. Jane, Henry, and Greg have a total of $97. Greg has $5 less than Jane. Henry has 2 times what Greg has. How much do they have in their wallets? So, what am I looking for specifically? How much each of them have, right? And there's 3 people. So I am looking for 3 things here, right? Money in 3 different people's wallets, if you will. Just like when we had 2 variables and 2 unknowns, we're going to identify what our variables are and what they represent. So like x is one of my variables, and that's going to be, I'm going to use that as Jane's money. I'm just going to go in order the way that they were given to me. Henry was who I was given next. So y would be Henry's money. And then z I'm going to let be Greg's money. All right, if you don't identify what x, y, and z are, then your equations aren't going to have context for you to be able to answer the questions at the end. Okay, so make sure you identify which letter corresponds to what quantity. All right, the first sentence says that they have a total of $97. What does that mean? You got it. X plus y plus z equals 97. Make sense? Okay. The second sentence says Greg has $5 less than Jane. So we need to write that in an equation form. So Greg's letter is z. And what is z according to that sentence? X minus 5. X is Jane, so whatever Jane has, if we subtract 5, we have Greg. And then our last sentence says Henry has 2 times what Greg has. So z, okay, I'm going to write it the other direction, but yeah. So Henry is y, right? So y is twice z. I feel like I have a typo with what I'd written from what I had before. I'm pretty sure I do. I'm going to fix it right now before we keep going. This should say Jane, based on the work that I've already done from before, and I know that the answer came out that way, so this should be Jane. So it's not 2z, it would have been 2x, right? Sorry about that, guys. Okay. You don't get to just change people's names, by the way. Oh, I get to do that, but you don't get to. Okay. Okay. This is good. It's good because it's a lot like that first one we did in the last section, right? I don't have 3 equations that all have 3 variables. In fact, the reason this one's even so much nicer is because this z is defined with x and this y is defined with x, which means I can do this almost like what I did when I do substitution, right? I have x and I don't know x, but I do know what y is. Y is equal to 2x. Had 2 0 there. 2x. And z is equal to x minus 5. And the sum of all that is what? Yeah, it's 97. Lovely. So how many x's do I have on the left? There are 4 x's. 4x minus 5 equals 97. If I add my 5, what is 97 plus 5? 102. And then what is 102 divided by 4? 20 what? 25.5. Okay, fabulous. So if x is 25.5, what's z? 20.5. I could probably write 50 if it bothers you because it's change, right? And what would y be? What is it? 51 is right. Yeah, 51. So these are my numbers that I get for x, y, and z. And I need to write out an answer with units. What are the units on this? Yeah, dollars. So I need to actually say what each represents. So Jane has how much? Yep, $25.50. How about Henry? Careful. Henry's Y. He has $51. And then who's my last person? Greg. Yeah, Greg has $20.50. Is it good? Okay, awesome. Like I said, this one's nice because I don't have legitimately 3 variables in every equation, so that makes it easier to solve for. The next one's going to take you just a little bit of time to write down, so I'm going to flip to the slide and just give you a chance to write. And then we'll read and process and think about it together. All right, so we have Layla, and she owns some fruit stands in 3 different locations: Thomasville, Newberry Heights, and Glen City. They sell 3 different types of fruit: apples, cherries, pears, and they sell it by the bag. So this isn't an individual cherry, right? That would be weird. And so forth. They're selling it by the bags, and each of the locations in a specific day has made a certain amount of money from the sale of their fruit. Thomasville sold $77 worth, Newberry Heights 43, and Glen City is, I'm sorry, 44. That should have said 44, that's a typo, and then 43, so fix that. Hang on, is that right? 67. So what happens? So the first one is 77, the next one is to be 67. Too many typos today, my bad. And the last one's 43. Okay, so that's what the numbers are supposed to be. And the question they're wanting to know is what the cost is for the fruit. Make sense? Okay, so if you knew how much the fruit cost, like let's say you knew that a bag of apples cost $5, could you figure out how much money that Thomasville made from selling apples specifically? If each bag cost $5, how much money did Thomasville make from selling apples? $30. And how did you get 30, Megan? Yeah, so you would multiply the price, which is what we don't know, by the number of bags, which is what we do know. Are you guys with me? Okay, so that's what we're going to end up doing after we define our variables. So we need to have 3 variables because there are 3 types of fruit, and I'm going to use X, Y, and Z. And I'm just going to go in order across or down my table. So I'm going to let X be my, be my cost of my apples. And it's cost per bag of apples. That's what I'm finding. Y would be my cost per bag of what? Per bag of cherries. And then that would make Z my cost per bag of what? Yeah, of pears. So again, like on the last problem, we're trying to create 3 equations because there are 3 things that we don't know. All right? And we're going to do it based on the location. So if I take Thomasville, for example, what equation am I going to be able to set up using my X, Y, and Z and the 6, 6, 5, and 5 that they give me from my table? I'll write it on this slide before I switch slides. What do you think that one's going to look like?
6x plus 5y plus 5z equals 77.
Right, and it equals 77 because that's how much money Thomasville made. You guys with me on that? Okay, so you have your table written down. I'm going to flip my slides so that we can keep working. But we said that this is 6x plus 5y plus 5z equals 30. No, I'm sorry. 30 was my number 4. 77? Is that what I had? Yeah, okay, good. How about my second column? What was it? Newberry Heights. What would the equation for Newberry Heights look like?
6x plus y plus 18 equals 67.
Good job, Keely. All right, so we had, where's my slide? 6x plus y plus 8z equals 67. And then our last location, Glen City, what would its equation look like? Very nice. 3 equations, 3 unknowns. And they're not near as friendly as the last 3 equations, are they? No, they look a lot like that second example in that last section that we just did, where we have a lot going on. In fact, in some ways, this one's maybe even worse because the numbers are bigger than that particular problem. So looking at x's, y's, and z's, which variable is going to be the easiest one to eliminate first? X, you do X. Okay, so if we do X, that would be this column right here. So I'm going to label my equations 1, 2, and 3. Let's start with equations 1 and 2. They don't work exactly straightforward as is. What do I need to do?
Multiply 1 by -1.
Yeah, we need to multiply one equation, and we'll just do number 1. No, because you need 2 equations when you're done. Yeah. You would end up, what would happen, Sarah, is you'd end up getting 1 equation, but you'd still have 2 unknown values, and you'd have nowhere to go from there. Yeah. Okay, equation number 1, all the signs are going to change then. So I have -6 minus 5y minus 5z equals negative 77. And then equation 2 is going to stay the same. 6x plus y plus 8z equals 67. Look good? Fantastic. So my x's, of course, go away. How many y's do I have? Negative 4y. And z's? Positive 3z. And constants? Negative 10. This will be my equation 4. Now, what do I need to do? Okay, we could do equations 2 and 3. Can we add them exactly as is there, or do we need to manipulate one of them? Okay, so we're going to multiply our third equation by negative 3. So my second equation stays the same. 6x plus y plus 8z equals 67. Third equation is negative 6x minus 9y. What would you do by negatives? Minus 9z. Okay, so what is 43 times negative 3?
Negative 129.
Nice. Those numbers get big fast, don't they? All right, so my x's went away. How many y's do I have? Negative 8y. This is negative 8y, right? Z's? Negative 1z. And then what's 67 and negative 129? Negative 62. Okay, so you guys are doing a great job of not using any of the same orderings I did in my notes. So this is good. It allows us to double check and make sure it's all right when we get to the end. Awesome. Equations 4 and equations 5, and I need to eliminate something. Do you want to eliminate y or z? Actually, there's justification for either one, so we just need to pick one. Which one would you like to eliminate, y or z? Y? Okay, what do we have to do to eliminate y? By what? Just 2? Okay, negative 2. All right, so I need to multiply negative 2 by equation 4. So I have 8y minus 6z equals 20. Is that right? And equation 5 is negative 8y minus z equals negative 62. Those add to 0. How many z's do I get? Negative 7z. And then what is 20 minus 62? Negative 42. So what is z? 6. Your numbers were actually smaller than mine when I did mine. They were much less ruly. Okay, I know z is 6. There's the right answer to this question. Which one's going to be easier to find next? X or y? Huh? Which one? Y. How come? Yeah, equations 4 and equations 5 have only those two variables in it. So Sarah wants me to plug it into equation 5, so we'll do that. Let's see, I have negative 8y minus z equals negative 62. So this is negative 8y minus a negative 6. So I have negative 8y plus 6. So what is 62? Did I get? Oh, it wasn't 6. It was positive 6. My bad. That was like, that doesn't going to be a nice number at all. Okay, let's fix that. So what happens when I take the negative 62 and I add 6 to it? Negative what? 56. Right, negative 56. And if I divide by the negative 8, what would y be? 7.5? I just have 7. I just have 7 in my notes. 56 divided by 8 should be 7. Yeah, it's okay. Typos happen, no problem. Okay, cool. That's the second variable. I still need to find x. I think over there. And then what? You want to use the second equation. Okay. That's what I'll do. I'll move this all up. Okay, so my second equation is 6x plus y plus 8z equals 67. I don't know x. I know that y is the one I just found, 7. And z is 6. Okay, what's 6 times 8? 48 plus 7. What is it? 55? Okay. Oh, that should say equals 67. Okay, and then if I subtract my 55, 6x will equal what? 12. So what is x? 2. X is 2. You can't write down x, y, z ordered triple. That's not appropriate here, right? Because we have context. What in the world do x, y, and z represent again? Yeah, the cost per bag of fruit that we were looking at. So if I start with, I'll start with x just because it's alphabetical order. X was what? What fruit? My apples. So my apples cost $2 per bag. Cherries was next. What do my cherries cost? $7 per bag. And my pears. Pears cost $6 per bag. And that's what the answer would look like at the end. Any questions on that? All right.